Okay, so we're going to just start out with some vocabulary. We're going to talk about functions and domain, range, composition of functions. I'm going to do a whole bunch with functions today and tomorrow. So here we go. So a function is a special relationship. Relay. Oh, and I totally just started to already spell it wrong, didn't I? Wow. Let's try that again. Relationship. Where each input has a single output. Right? And it's often written as f of x. Okay. F is my function name. X is the input. You've also seen g of x, h of x, r of x, a of x, b of x, tons of with a different function name here, just in parentheses with x there. So that's a definition of a function. I'm going to slide up so I can put domain and range on the same thing. So domain is all the values that go into a function. So the x values. And I want to make sure when I'm writing domain, I go from least to greatest. It's always my smallest to my greatest. And range is the set of all output values. Oops. Sorry. Output values of a function, or the y values. And again, I always write those from least to greatest. The other thing is between domain and range, if my endpoint, right, is included, I use brackets. And if it is not included, I use parentheses. And if I have infinity or negative infinity, I always use a parenthesis because we don't know where infinity is. So when we're talking about domain and range and using interval notation, this is what I use. As long as I know that that it is a continuous function. So if I'm just given like a set of points, we're going to get to that in a second, but I'm going to talk about it now. If I'm just given a set of points or a discrete graph where I have to list out the points individually, what I'm going to use is the set notation, which is these like little curly Q brackets. Duh. I call them sideways birds because that's what I am recording, by the way. Sorry, Kim. If you look down at the bottom, down here at the bottom of the screen, you can see where the record button is, and it's telling how much time we've got recorded. I'm just not recording on Zoom. I'm recording on my iPad. Okay? Sorry. Just saw that. So I'm recording on the iPad now. And then what will happen is I will save the videos to my YouTube channel and then put the link into the Canvas page. The problem is Canvas is we've literally, I guess, used 800% of our storage space with Zoom with videos. 800%. So I had to find a different way to do this. So I just decided I'd try this, and it worked last week. So I'm just recording now on my iPad, and I'll upload it to my YouTube channel and then put the link on the Canvas page, on the lesson page that it goes with. So it'll just either there or with the completed notes. I haven't decided yet which would be easier. So, but that's where they will be at. Sorry, people just keep coming into the room. Okay, so now we're just gonna, oops, do this next part. It says for each correspondence, find the domain range and determine whether it is a function. So we're going to find the domain and range and then say if it's a function or not. So for the first one, my domain, the domain is all the x values. So if I just do the x values here, and they're in order from least to greatest, and it's a point, so I'm going to use my set notation. Just the x values, so 0, 1, 2, and 5. Questions? Could I go up again for a second? Yeah. Sorry. Okay. Are you just going to take a picture, or do I just let me know when you're ready to go on? Again, I tried to put these in OneNote, so if you guys want to go into your student note, but I don't know how it works on your end. I guess I could have went in as a student and checked it out. But these are now in OneNote, so you should be able to get in there. Okay. All right, so there's my domain. My range is all my y values, so -1, 3, -1, 3. And it's in order from least to greatest. And the other thing is, if it's more than one time, I don't have to write it more than one time. I only have to write it once. So there's 2 -1s. I only have to write 1 -1. And there's 2 3s, and I don't have to write 1 3. And there's my range. And then my definition for function says basically for every x, there's only one y. And I don't have any x's. And I kind of just look at my x values. Do I have 2 of the same x values? Well, no, I don't. So basically, this is a function. Okay? Questions? Everyone okay with that? Okay. So we're going to do the next one, the same thing. So I've got my domain. In order from least to greatest should be -2, -2, 3, and 4. And then my range is what's left, and I've got -8, -2, 4, and 5. And if I look, I've got 2 4s. Each of them have a different y. So this is not a function. Okay? So now it's your turn. You're going to do A and B. Go ahead and do it anyways. Okay. So my domain for A is, let's see, -3, -2, 0, and 4. My range is, let's see, -10, 3, 5, and 9. And this is a function, because there's only one of every x. Okay, and my domain on part B is 1. My range is 1, 2, 3, 4, 5. And it's not a function because I have the same x that goes to 5 different y's, so this is not a function. Is there any questions on function, not a function? If I have a point, if I'm given a point, how to find it? Are we okay with that? All right, so now we're going to go to the next thing here. Okay, so we're going to do kind of the same thing from a graph, although we're going to kind of evaluate it a little bit. We have to do 4 things, 4, for each graph. Okay, so for each graph, I want to find out where f of 1 is, the domain, any x values where f of x equals 2, and the range. So I have to do 4 different things. So I'm going to kind of make this a little bigger here. So I want to find f of 1. So in my graph, wherever x equals 1, right, this says x, if x equals 1, what does y equal? So in my graph, if x equals 1, what does y equal? Sorry, I need to look at my graph a little better. I think it says -8 there. Okay, everyone okay with that? Please let me know if you are not understanding something we do here. Okay, so my domain, and sorry these don't have arrows on the end, but this should have arrows on the end. Sometimes it's hard to find graphs with them. So since they have arrows on the end, it means it goes on forever. So my domain would be -infinity to +infinity. Okay? And then the next question's a little harder because it says f of x equals 2. So this says y equals 2. What does x equal when y equals 2 is basically what it's asking. So I'm going to go to y equals 2. Y equals 2. I'm going to blow up the graph really quick. Is that okay? So you guys can see it a little better. So here's my graph. At y equals 2 is here. And I need to know what x value y equals 2 at. Well, it equals here at -3. Here at like, -0.25. And notice I just kind of estimated that. Do I know that's the right one? No. Am I estimating it? Yes. It's okay on some of them. Okay? And then here at 3. So my answer for this would be -3, -0.25, and +3. And then the last question they asked was, what's the range? So my range on this also, there's arrows, it's going forever. So -infinity to infinity. Questions? This is all stuff that you should have done before. So, but I just want to make sure that you can do it. Okay, so same thing on the next one. I have a different graph this time. So I've got f of 1. So at 1, let's see, my graph is 1, 2, 4 equals 4. Okay. My domain, I got arrows on the end. They're going forever. So this is -infinity to infinity. What does x equal when y equals 2? Well, let's see. Y equals 2 is here. So x equals 4. And then the last one was what? My range? So my range on this one's a little different. Even though we have an arrow here, it's a straight line. It doesn't go lower than this line, right? It's a constant. So it's not going lower than that line. So my domain, my lowest on my, sorry, not domain, my range, my lowest on my range is going to be -4, and it's going to be included because it's a solid line. It's included there. But because my arrow here does keep going up, it's going to +infinity. Questions? You guys think you can do it? Because you got like, I don't know. I'm not sure how many there is. 3, at least 3. Oh, 4. You have to do 4 of them. So, oh, sorry. Stop. Thank you. Okay. So f of 1, if I go to x equals 1 and I go up, it's right here, so it's 3. My domain goes from -4 to +3. When y equals 2, so I'm going to go to y equals 2 and go to my graph here. X equals -3. And then my range goes from, this is the only time I use y values. My range goes from -2, and then my highest point is at 5. Okay? Okay. Oh. So on the second one, second one's a little harder, just so you guys, especially the domain and range. So f of 1 is negative 2.5. And I think a lot of people are putting 2.5, but it is in the negative, so I have to have that negative sign there. My domain is great. It's got the arrows on the end, right? So it's going forever, except for 1 point. What is not included in my domain is right here because it's an open point. So that means my domain goes from negative infinity to 5, and then 5 to infinity. 5 is not included in my domain because it's open at 5. Okay? And then f of x equals 2. So when y equals 2, what does my graph equal? Well, nothing, because it's open. It's not included at y equals 2, so there's nothing there. Okay? And then the range on this one also has an open spot in it. So, and I'll accept either answer because this graph is kind of funky, but I would say it would go from -4, never going to touch -4 because it looked like it's flattening out there. Or you could say negative infinity, whichever one, to 2, because there's an open hole at 2, and then 2 to infinity. I don't care which one you put, I'll accept either answer. Okay, because that graph's kind of weird. Okay, 2 more. 2 a little more harder. Same thing. Okay, so I want to talk about the first graph for a second. Because most of you got it correct. So let's talk about the domain first. If we look here, this one's not included, but it is included here, not included, included, which means my domain from -4 to 5 is not broken. There's no breaks in it because it might not be included up here, but it is included here. So there's no break here. Same here. It's not included here, but it is break there. So I can actually write my domain as -4 not included to 5 included. So some of you wrote it that way. Some of you wrote every point out between there and there. The difference between this and writing it this way, I'm going to just go ahead and write it. So some people wrote it 4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Sorry, I ran out of room. Is that on this one here, this only includes those points. That's it. No points in between them. So like with this graph, I have a -2.5. I have a 0.5. I have a 1.5. I have a 3.5. This here, this one over here doesn't include those half points. Whereas this one includes everything, every little point between -4 and 5. Does that make sense? Are you okay with the difference between that? This one has every single little point between them. This one only has -4, -3, -2, -1, 0. Does that make sense? Are we okay with that? Okay, so now if we're going to talk about, now we can say the same, sorry, I need to erase this so I can go on to the next one. We can say the same thing when we're talking about when y equals 2, what does x equal? Well, it's right here, right? It's everything between here and here. So I want to write that as interval notation, which means 2 is not included, 5 is included, because it's every single little point in between there, not just 3, 4, and 5. And some people did write it that way. They wrote 3, 4, and 5. So it's not only 3, 4, and 5. It's 3.5, 4.5, 3.25, 3.75, every single number between there. And it's also 2.5. So it's everything in between there. So I want to write that as interval notation. Okay? And then actually most people got the domain right. The range right. Wow, I'm having a bad morning. The range right. Most people wrote it out individually because there is nothing in here and there's nothing in here. So the only range is just -1, 1, and 2. And most people wrote that one out correctly. That was very, very good. Okay? Does that help you with the next one and your domain and range and everything on the next part? Because on the next one, there are no lines. It's only points. So that means instead of writing it out interval notation, like I did on this one, I'm not going to write it out this way. I'm going to write it out this way. I have to write every point out. So if I'm doing f of 1, I get 3, and all the answers I solved for that was correct. That was great. My domain, however, since I don't have the -3.5s and the -2.5s and the -1.5s, I have to write every single x value out. So this would be -4, -3, -2, -1, 0, 1, and 2, I think. Okay, and a few of you got that right. That was great. Okay. And then when y equals 2, what does x equal? Well, we're right here. And we've got -2 and 1, no parentheses or brackets or anything, just -2 or 1. And then, not 1. Wow. Okay, 0. Okay. And then my range, again, I don't have the in-between values. So my range would be 1, 2, 3, and 4. Okay, is there any questions? If I wrote my range, some of you guys wrote it like this, between 1 and 4. That also includes my in-between values, like in here, and I don't have any in-between values on here, so I can't write it this way. I have to write it this way. Do you guys see the difference between interval notation and set notation? Okay, awesome. All right. So we're going to go on. So when there are no lines is right. No, when there are lines, I'm using interval notation. This is interval notation, which you've been using with the brackets and the parentheses. Set notation, when there's no lines, I'm using set notations, which is like the sideways bird set notation brackets. I don't even know what they're called. Okay, I just call them set notation. Okay, are we okay with that? And then I have to write out all the x's and all the y's. Okay, awesome. Awesome, awesome. Okay. So we're going to go on to the next page in our notes. And this one, super easy. All we're going to do is determine whether it's a function, whether the graph is a function or not. Does anyone know how you tell if a graph is a function or not? Can anyone tell me? Does anyone know? What do I do to tell if a graph is a function or not? You can either type it in the chat or say it. I don't care.
Vertical line check.
The vertical line test, yeah. So vertical line test says if I drop a vertical line, right, and all of these are vertical lines, and it touches in more than one place, it's not a function. So if I could, I would slide this along, but unlike my smartboard, it doesn't allow me to do that. If I could take this vertical line and slide it, you could take your pencil and slide it along, or a piece of paper and slide it along, however you want to do that. As long as it doesn't intersect in more than one place, it's a function. And this one is a function. Okay? If I dropped a vertical line on the second one here, there we go. Look, it intersects in this place and this place. Not a function. Is there a question on how to find out if a graph is a function or not? Are we okay with that? I'm looking at the chat box.
Yeah, could you repeat that, Ms. Temple?
Yeah, so if I drop a vertical line, right? Vertical line's vertical. I don't know how else to say it. And it only intersects the graph in one place, then it's a function. if like on this first graph, right? This one only intersects in one place. And no matter where I drew that vertical line in, it would only intersect in one place. Then it's a vertical, and then it's a function. This one, on the second one, and I dropped this vertical line and see how it touched the graph in 2 places. Not a function. Did that help, Kim?
Okay, I get it.
Okay.
Thank you.
You're welcome. So I want you guys to do the next 4. All you have to do is write function, not a function. F, NF, I don't, however you guys want to type it into the chat box. There should be 4 of them. It shouldn't take you too long. I'm going to pause for. Okay, so number 1, if I drop a vertical, or sorry, number A, if I drop a vertical line, it's not a function. B, if I drop a vertical line anywhere and slide it along, it would be a function. C, if I drop a vertical line, not a function. And D, if I drop a vertical line, it's only intersecting in one place, function. Is there a question about any of those? I do it typing too. I'm so bad at typing, just so you guys know. I'm reading some of your comments. Sorry. I'm so bad at typing. Okay, so the next one is we're just going to find the function value. Okay, so we have, I don't know, how many is this? 6 problems. I've got a function here. I'm going to plug in my x value and find out what it equals. So the first time I'm going to x equals 0. So wherever there's an x in my function f, I'm just going to plug it in and see what I get left with. So that means I've got 0 minus 3 all over 2 times 0 minus 5. So that's going to equal negative 3 over negative 5, or 3/5. Positive 3/5. Questions? Awesome. Okay, I'm going to do the same thing here. Instead of a 0, I'm going to put in a 4. So I've got 4 minus 3 all over 2 times 4 minus 5, which is going to equal, let's see, 1 over 8 minus 5, or 1/3. Is that good? Is that right? That's right. I know that's right. I don't know why I'm asking. Okay. Then for the next one, I'm going to put in -1. Make sure if you have questions, you ask, okay? So I know you've been doing this for a couple years now, so you should be able to do this one. So it's, what is this? -1 minus 3 all over 2 times -1 minus 5. So that gives me -4 over -2 minus 5, which is -4 over -7, or 4/7. Okay. Lovely. So the next one's a little different. It says f of 3 plus 5. So what it's going to ask me to do, it's going to ask me to find f of 3, and then after I get my answer, I'm going to add 5 to it. So I'm going to find f of 3 first, and then I'm going to add 5 to my answer. So I'm going to find f of 3 first, which gives me 3 minus 3, oops, I should put an equal sign there, over 2 times 3 minus 5. And 3 minus 3 is 0, all over 6 minus 5, 0 over 1 equals 0. And then it says 0 plus 5 equals, oh, that's a really ugly 5, but it's a 5. 5. Is there questions on that? Awesome. Okay, and then for the last two, okay, for the last two, oh, gosh, I need to see the problem. I'm so sorry. Let's see, I've got x plus 2. Wherever there's an x, I'm going to put in x plus 2. So I've got x plus 2 minus 3 all over 2 times x plus 2 minus 5. So that gives me, let's see, what does this give me? X minus 1 all over 2x plus 4 minus 5, which gives me x minus 1 over 2x minus 1. Done. Questions? Okay, same thing with the a and the h. Wherever there's an x, I'm going to put a plus h. So I've got, what do I have? I've got a plus h minus 3 all over 2 times a plus h minus 5, which gives me a plus h minus 3 all over 2a plus 2h minus 5. Can't do anything else with that. You guys feel okay with that? So-so? Okay, well, I think it's your turn. Yep, your turn. Okay. Let's see. Oh, there we go. So g of 0 is 2 times 0 plus 5, which equals 5. G of negative 4 is 2 times negative 4 plus 5, which is negative 8 plus 5, or negative 3. Let's see, we've got 2 times negative 7 plus 5, which is negative 14 plus 5, which is negative 9, pretty sure. And then we've got 2 times 8 plus 5, which is 16 plus 5, or 21. You're welcome. And then we've got 2 times a plus 2 plus 5, which is 2a plus 4 plus 5, or 2a plus 9. Almost all of you guys got all this right, by the way. There was a few of you. Okay. That got some interesting answers. So then I've got 2a plus 5 plus 2, which is 2a plus 7. Questions on any of those? Sorry, I just looked up and saw some interesting answers on E and F in the chat box. So, questions on any of those? Are we okay? Awesome sauce. So, let's see what we got. Okay. So we're doing the same thing for this one. Go. And hopefully it'll come out when we get done. So I'm going to just go ahead and do this. So I've got, and you'll have to see if you got your answers right. 3 times negative 1 squared minus 2 times negative 1 equals 3 times positive 1 plus 2, which is 5. And then g of 3 is 3 times 3 squared minus 2 times 3. So 3 times 9 minus 6. 27 minus 6 is 21. And then we've got 3 times 2a squared minus 2 times 2a, which gives me 3 times 4a squared minus 4a, which is 12a squared minus 4a. And then d is g of 3 minus 4. Well, g of 3 we already did. G of 3 is 21, so this is 21 minus 4, which is 17. Okay, not too bad. Sorry, I can't see your chats right now. I got to try and fix the Zoom or go in through. So if you have a question about it, you need to say it out loud. Okay. So you have about 12 minutes to work on Delta Math.